Hey everyone, I'm Robert from Cheeks.com. Today I'm going to be talking to you guys about my latest project, building a laser cutter stand for my K-40 laser you can see behind me. I live in an apartment, which actually makes it a little bit tougher for me sometimes with some of my projects, especially when using my laser cutter. Not going to do it inside, I don't want to have any smoke damage. So at my old apartment, I actually had a desk with wheels on it. I was able to wheel it in and out pretty easily. But at my new apartment, it came with a built-in desk, which actually make it a little bit tougher for me, uh, since now I have to figure a way to store and move my laser and make it a little bit easier for myself. So I decided I was going to make a stand that'll collapse down so it'll make for easy storage, and that's kind of what I'm going to talk to you guys about today. A little bit about the materials that I used, mostly using my 3D printer for the hinges, for the joints, and everything else that I needed for um, in order to make it a mobile device. So stick around. So I was talking to my friend Mark from Teapot 3D about this project. I wasn't quite sure what materials to use. I knew I was going to use the 3D printer in order to print a lot of the parts, the hinges, and different things. But I wasn't sure what I was going to use for the actual legs of the stand. He actually happened to have a bunch of extra 80/20 aluminum extrusion parts, which look like this. As you can kind of see, they've got channels. It allows you to actually lock parts together without having to weld or anything like that. It is pretty lightweight and it's very sturdy, so I figured I'd give it a shot. It's my first time working with the material. I don't have a full shop, so I ended up having to use a hacksaw to make some of the cuts, which I'm sure you guys know is not all that accurate. So I had to make some adjustments with some of my printed parts in order to accommodate for that. But at the end of the day, it is going to be a good material. It's sturdy. It's going to last a long time. And that's what I want. All right, you guys, so I'm going to go through some of the design aspects of what I put together for this project. I did start out with a couple of more basic things like this hinge that I designed. It's fairly simple. As you can kind of see, there's some tabs here that will actually fit into this portion here, so it'll actually rotate as it's printed, uh, rather than having to put it together afterwards. I also added a slot here so I could actually add some bolts, add some extra stability. Um, Now, what I ended up doing here was I took a measurement of a channel that it runs along the underside of the K-40 printer. Um, One half of this would fit in there, the other half would be on the outside. And again, room for a bolt. I ended up actually using some self-tapping screws to hold everything together there. Now, from there, I used that design in order to put this together, where this actually fits on the end of the 80/20 material. Again, I was able to use some self-tapping screws to hold it in place, make sure it wasn't going to move anywhere. But those are the exact same hinges that I had designed initially. Now, after that, I printed those, made sure that they fit. They actually went on perfect. Tested it with the channel, was strong enough to hold. Again, the K-40 printers aren't super heavy, so it worked out pretty well. I used that same tab portion in order to design this other part, which is essentially the hook where the stand will be able to release half the legs, uh, and I can actually fold it down flat. So I wanted to design these here so what I could do is I could actually have it on there to lock in fairly firmly, and allow me to do that. Now, to pair with that, this actually goes on the other two legs. So this portion here goes on two of the legs on one side. This portion goes on two of the legs on the opposite side. Now, as you can kind of see, again, it goes over the 80/20 material on the end. It bolts in, and then here I'm able to actually use this tab here would fit into this opening right over here, right? So it actually worked out really, really well. I only had to design that portion one time, and it actually worked out fantastic. Now, so those are the top ends, the parts that are actually mounted to or connect to the laser. Uh, what I also needed to do was create some pivots for between the legs. So what I ended up doing was, again, I used that channel design to actually slide into the 80/20 material, right? Again, self-tapping screws here. Um, Printed it, and then I added this portion here in the center, almost like a heavy-duty washer, which is also 3D printed in order to allow it to rotate, cause less wear on the individual parts. If I do need to replace a part, hopefully it's this and not a whole side, which would make my job a little bit easier. Um, so that worked fantastic. I took some measurements, made sure I put them in the center of the legs, and it worked out fantastic. Um, Now, one of the other things that I needed to do was to create a spacer to go in between the legs and set in between the two interior legs in order to make sure it was going to stay stable and they weren't going to be wobbling around. So I was able to design this. Again, it's that same design that I initially put together. Um, if you guys do want to see that, I can actually pull that apart here, and I'll do that in a second. But again, it slides right in. Same thing, self-tapping screws, built-in spacer. Uh, I tested the legs with and without this spacer in, and it changed the stability of the stand immensely. Um, Beyond that, on one side of the laser, I put some wheels, just some regular normal caster wheels. Um, and then on the other side, I actually designed these out, which are essentially pads for the foot, where the 80/20 material would sit kind of in this direction, right? It actually bolts in here. Um, and then this bottom portion here, when I printed it, I used TPE material in order to enhance the grip on the ground, so we don't have any slipping or anything like that. Again, worked out fantastic. And then the last parts that I did for the stand, at least, I printed a handle, right? So we've got some slots here. Again, I was able to use some screws. I actually used bolts on this one. Put it through the sheet metal and then was able to connect it all on the inside with bolts. Fairly simple. All right, you guys, so just kind of give you an idea, the material that I use is 80/20 material, has T-channels built in. So what I ended up having to do was design a part that would not only fit snugly around the exterior, but also would fit into this T-channel, allowing me to bolt it together. So what I ended up doing was designing out these parts here, which is actually three separate pieces. There's this piece here that fits in between from the exterior to the interior gap. Then there's these two pieces here which fit again into this T-channel, and I designed this out first, right? Put that kind of all together, and then what I ended up doing for these pivots that I designed was I had to create a gap here to allow for the bolt for the legs to actually pivot with each other. As you can kind of see, this overhang material here would not normally print well due to the fact that it's not actually printing onto anything, and it would just kind of throw filament down. So what I ended up doing, rather than using the supports that you can use that come uh, preset in slicer programs, is I actually created my own, making these about a 1/2 millimeter thick, as long as I needed them to be to fit in those portions, and then uh, putting them in that gap. Now, I don't, it's kind of tough to see, but you can actually tell that I leave a slight gap between the material on the top as well as on the bottom. What that does, it allows me to remove them a lot easier. Again, the preset ones that come in slicer programs tend to be really stuck on there. So this makes it a little bit easier to remove. And the way that I'd leave that gap is I just make the pieces about 2 layers shorter on the top and on the bottom of the piece in order to allow me to kind of just pop them out when I need to get them out. So that's definitely a tip. If you're going to be 3D printing, definitely a tip that you're going to want to take into consideration. So most of these parts are really simple to print. Essentially putting them into cruise control, setting the material, the quality, the infill. But with these pads that I made for the legs that do not have wheels, it was a little bit different. I think I talked about this a little bit as far as doing a layer change. Did a little bit differently this time. essentially what I had to do was I set the settings to PLA, draft, and then for these first 4 layers, I actually used the TPE material that I bought, and then did a layer change at 1.1 millimeters in order to switch it into the regular PLA. Now, the good thing about this printer, the Teapot printers, is that in order to print this TPE material that I'm using, I can use the same PLA settings, but while it's printing, I turn the print speed down to 60%. It prints really well like that, and then once I switch it to PLA, I turn the print speed back up to 100%, and it works great. So as for this part, one of the things that I did have to do differently with this piece is I had to, again, add some structure, removable structure, so that it would actually print and I wouldn't have the top collapsed after the print. So as you can see, these lines here in the center, those are just structural that I'm going to have removed. But as you see, it kind of goes up until there, and then it starts the flat layer. And then once the print is done, I pull it off the bed and I just kind of break those out. They tend to come out pretty easily. I'm just dreaming. I've been sleeping less, but I've been dreaming more. Working hard, I don't shop much, but I can't wait to see what's in store. What's in your wallet? Probably nothing more than $1 debit card and a rubber 4. That one time she might let you explore. Hold up, you ain't ready for that.
So I didn't do this earlier, so I went ahead and printed a model piece, a lot smaller than the actual hinge that I've used. But I wanted you guys to see that essentially this is printed all in one piece, but it allows for that movement of the part. This part I hadn't actually unstuck yet, so all I had to do was rotate it, boom, and it went ahead and it functions just like I wanted it to. Alright you guys, so I finished up building the stand. I've got it kind of on its side here so I can show you guys. So a couple of things that I had to do is I had to modify these casters. I bought them before I knew what the material I was using, before I got this 80/20. So I ended up having to modify them there. But they're on there sturdy. You also got the pivots here, the blue piece in the middle there is the washer. Spacer. You've got the foot pad where this part here is the rubberized material and this is the regular PLA plus. Again, I have another spacer up at the top half here. Now I did modify the hook, right? So as you guys can kind of see here, it's a walled structure rather than just a plain hook, right? And I found that that gave it a little bit more stability as well. So just to kind of give you guys an idea. Again, mostly just use self-tapping screws for most of these parts. The hinge here as well, right? Where I've got, again, it's bolted in here, right? And then you've got the accessory bolts there, right? Again, self-tapping screws to mount to the body of the laser. And then the air hose, I've got the adapter here that I kind of built in, right? So just kind of give you guys an idea. All right, guys, to give you an idea of how I break it down, I'm just gonna take both hands, pick it up, unhook, drop it all the way down, right? Lays down pretty flat, and then to bring it back up, a little more complicated. You gotta kind of tilt it up, bring the hooks up, drop them in place, and then tilt it back over. And that's it for this video. If you guys have any questions or comments, leave them down below. Big shout out to Mark over at Teapot 3D. Like and subscribe down below. Be back soon.